Ingesting data is an important step in getting data prepared for high performance. As data is ingested into Firebolt, it's physically sorted, compressed, and indexed. This sets the data up for extremely efficient querying. Firebolt supports two types of internal tables: fact tables and dimension tables. This doesn't limit us to dimensional modeling, but it does allow us to alter how tables are stored and managed. Fact tables are distributed amongst the nodes in an engine, while dimension tables are effectively mirrored to each node in an engine. Firebolt offers two paths for ingesting data: the copy from statement and external tables. In its simplest form, we can point the copy from statement at a bucket, give it the target table name, and it will infer the file type, schema, create the target table, and populate it. This is very useful for ingestions that require staging data before transforming it and loading it into the final production table. It also allows for loading existing tables using column mappings as well as populating metadata from the source, including fields like the file name and last modified date. Here, we'll create a new internal fact table and populate it using field mapping. External tables allow for querying data in object storage directly. This allows for the full use of the SQL language at ingestion, including transformation like joins and complex functions. External tables are created using the same familiar DDL as any other SQL table, with a few added attributes. First, we use the external type identifier. Since there is no schema inference with external tables, we define the columns as we would in any table, though it must match the source file schema. External tables will function like any internal table in Firebolt, but will be much slower as they're out in object storage and completely unindexed. Here, you can see that selecting everything from the external table takes 0.61 seconds, while the same query against the internal table takes 0.08 seconds. In this case, we're selecting only those rows with a file modified date greater than the maximum we've already ingested. We're referencing an internal table in a subquery, but this could be achieved through left joins, CTEs, or any other SQL functions, allowing for very complex transformation on ingestion. Thank you for your interest in Firebolt.